is we're going to talk about the rate law. Maybe. Did I start that twice? Okay, we're going. Sorry. All right, so rate law. Rate law is very easy to do. All you have to remember is a simple equation, and this is the equation. It is rate is equal to K times the concentration of something, say A to the X power, times the concentration of B to the Y power. Now, most times rate, you have to have experimental data because it doesn't necessarily follow the equation. But if all you have is the equation, you can do a rate law as a prediction. And that's what we're going to do in number 1 here, is we're going to predict what the rate law would be. So, looking at this, all you worry about is the reactance. Okay? So all you worry about is the reactance. So we're going to say for A here, because we're going to write the rate law, is rate is equal to some constant times the concentration of S2O8, 2 minus, to the coefficient of what is there, which is 1. And we don't write 1 coefficients, right? Times the concentration of I minus to the coefficient, which is 3. This is our prediction. It doesn't mean it's correct, but it's our prediction. The next thing is to determine the order with respect to each reactant. This is easy. All the order is, and you have to write it this way, the order with respect to S2O8, 2 minus, is whatever the coefficient is, which is 1. For the second one, all you have to do is do the little quotes. 2 I minus is, what would it be for I minus? 3. Because that's what the coefficient is for that one, or what the exponent is. So you're really actually looking at the exponent. So the exponent for S2O8 is 1, so that's the order. And for I3, it's 3. Or for I minus, it's 3. So
that was in front of it up there.
And this is just predicted, and we'll show you in just a minute how we actually find it. It won't be the same. Okay, this is a predicted. So we're predicting that this is what the rate will be, and these are what the orders will be. Okay, we're actually going to prove that wrong when we do the next equation. So for C, the overall order is 1 plus 3, which is 4. So that's pretty easy, right? Just add them together. Okay, pretty easy, right? The order means how fast it will appear or disappear. Okay?
Appear or disappear, like dissolve?
In a reaction. In a reaction. So I have to watch just that. Now we're going to slide down to number 4, which is actually experimental data for this reaction. Okay, and we're going to figure out what the rate order is. So we're going to come down here a few feet forward. Whoops, went too far. And we're going to look at this. Now we've still got the same thing, but this time instead of actually writing the numbers in that we had here and here, we're going to put them as x and y and solve for them because we have data. So our general equation is rate is equal to K times the concentration of SO3, 2 minus to the x and I minus to the y. Now, I purposely left these blank on the back because you might need more space. Okay? If you write tiny, you might be able to get it done. If you don't write tiny, there's more room on the back. Okay? So what we're going to do is you'll notice that I is held constant here and here, right? And S2O8 is held constant here and here. Now we can use that to solve for the thing that we don't have. So we can take two equations and divide them by each other and solve for what we don't have. So let's take the first two equations and we're going to set them on top of each other. So we're going to say rate 1, 1.14, divided by experiment 2, 1.70, equals k of the top equation, which would be S208, which is 0.15 to the x times I 0.21 to the y. And on the bottom for experiment 2, we're going to put k is equal to 0.22 to the x and 0.21 to the y. You see what I've done? So I've just taken experiment 1, and that's the top one right here. This is experiment 1, and this is experiment 2. Okay, can you see what I've done? Now, doing that, the k's will cancel. What else will cancel? The y one. So this thing will be out, right? So now I can rewrite this 1.14 divided by 1.70 equals 0.15 divided by 0.22 to the x. Is everybody okay with that? Just following math. How do I solve for the y, or for the x? Log. Good. So I'm going to take log of 1.14 divided by 1.70 equals x log of 0.15 divided by 0.22. Somebody give me x. If you need a calculator, there's some over there. I got the box out, or grab your own. Take the log of this number, divide it by the log of that number. How many significant figures should we have? 2, that's right. 1.0? Okay, 1.0. Okay, so far that's okay, right? All right. So let's do the other one. We're going to do the other side now, and I'm just going to put a line here so I keep track of which one's which. This is the order with respect to the S208 2 minus. Okay? So that's with the order with respect to that, because they're asking us with respect, the order with respect to each reactant. So we're going to need that is 1. So for that one, it's 1. Now we're going to do the other one over here. I'll change colors. We're going to do the bottom 2 experiments. So we're going to get rate, which is 1.70 divided by 0.98. So we got to have something the same so it'll cancel out so we can solve just for one or the other. Right. So whatever I hold constant, I'm finding the other one. Okay, so on this one, I'm holding this 208. But I'm going to go ahead and write it down so I don't mess up. So over here, we've got 0.22 to the x. And I'm still going to hold it as x because I don't want to put the 1 in right now. And I've got 0.21 to the y. And then on the bottom, k, I've got 0.22 to the x and 0.12 to the y. So again, k's will cancel, and that will cancel. Everybody okay with that? Then you're going to rewrite it. 1.70 divided by 0.98 equals 0.21 divided by 0.12 to the y. Then we're going to log it. And we're going to be able to find y. Uh-oh.
So y is just a representative of the order of I.
Mm-hmm. Ah. So this was one answer right here. Yeah. But I did. Yeah. Okay, so what do we get for y? Okay, we got 0.98. How many got 0.98? Okay, 0.98 wins. Okay, so that is 0.98. Is that different from what we thought it would be? Yeah, because we thought it would be 1 or 3. So this is the order. So the overall order is what? 1.98. Good. That's another thing that I need. So now we've written each respect, we've written the overall order of the reaction. Now we need to calculate K, and we need to write the overall rate law. Okay, so I'm going to go to the next page, and I'm going to keep that. So I'm going to go write what I know. Rate is equal to K times the concentration of S2O8 2 minus to the 1 power, and I don't really want to write 1. So I'm just going to write that, times the concentration of I minus to the 0.98, right? Same question. So now I need to solve for K. I would like U4 right here to use equation 1 and solve for K. I want U4 right here to use equation 2 and solve for K. And the rest of you use equation 3 and solve for K. Okay, experiment 1, 2, and 3. So take each of those experiments, just one of them each, and solve for K. So I'm going to put that equation thing back up here so we can see what's going on here. Yeah, I will. I'm just going to bring this down. So use the information here, plug it in, and solve for K. 1 is 1. Right. In each group that I broke you into, I want one person to be the spokesman and come write up what you got for K. We had 2, so all we can have is 2. 2 sig figs. You got to all agree on what number you're putting up.
Are you done yet? Why'd you steal my color?
Yes, that's not an eraser right now. No, it is. It was on the square. Right, so do it all the way through, get your K, and then take it to 2 sig figs. Okay, we got one more group. What's your K? Not at the very end. If you sig fig all the way through, yeah, but you got to wait till the very end to do your sig fig. Not really, because if you only have that many sig figs, that's like somebody measuring the room with a ruler. And that's 12 inches. Somebody that measures the ruler with a meter stick that only has the meter stick mark, and somebody measuring it with a tape measure. You're going to get different answers, different accuracies. So it's all about accuracy. Okay? All right, so 2 of them are the same, 1 of them is different. Okay? But they're within the sig figs, because what does sig figs tell us? That last number can be off by 1. So we're good. So it doesn't matter what experiment that you choose to do, you'll get what you need. Okay, we're going to go with 36 as our K. So I'm going to rewrite this, and I'm going to say rate is equal to 36. Now, when you get to AP, if you're going on to AP, we would have to figure out the units on K. Not a big deal, but that's all. Then we're going to go bracket S2O8, 2 minus, bracket I minus O98. So we'll go, this is one answer, and this is our last answer that we need for this problem. That's the last answer we need for the problem. So we have answered everything. We've determined the order of each. We've written the rate law, which is right here. It has to be a complete rate law. We've determined the overall order, and we've calculated the K. Okay? So you have, on the next page, you have 3 or 4 problems that are like this. Okay? They're not hard. You just have to work it through. Okay? All right. And you have 2 and 3, which are predictions. Now, let's go on to your lab. This lab, you'll have a couple days in class to do. A few days, actually. And this is what your lab looks like. Let me see if I can bring it up a little bit more. You've done this lab?
Yeah, we did.
We have?
We didn't do it in regular. This doesn't look familiar. I remember doing it. That's how we knew it was like big.
Good. I didn't think you guys had done this lab.
Yeah, so now we don't have a lot. I could show you, but I don't know my lab.
Awesome. Okay, so we don't need to do this. So you just have time to do the rate law then. Okay. It's a good review, so go make sure you go over that.